Alright, so I have to restart the video because I got interrupted in the last one, but here we were eliminating the parameter, which basically means find the rectangular equation. That just means eliminate the t. So here the first thing I did is I picked one of the two equations and I solved for t. So there's my t equals 1 over x squared minus 1. You guys can pause the video to see how that was done. The next thing is I'm going to use the second equation, which is y equals, and now I'm going to plug in what my t is into all the t spots. So it's 1 over x squared minus 1 over 1 over x squared minus 1 plus 1. And now we're going to solve this algebraically. I'll let you guys figure that one out, get a common denominator, flip the guy, multiply, do all of that, and you should end up with y equals 1 minus x squared. So that is our rectangular equation for these two parametric equations. So if you graph this right here, 1 minus x squared, you should end up with, well, you should end up with a full parabola, but of course we eliminated the parameters, so that's why it's not going to be exactly the same. Alright, so our parabola is probably going to be like this. Alright, I'm going to leave this example for you guys. Well, actually, let's just do it together. Okay, so here is my TXY table, and our parameter for this specific function is not given to us. So we need to figure out what the parameter is. Now, because this is a cosine and a sine function, basically, actually you should have told us our parameters. I forgot to put them in. Our parameters are within the unit circle, right? So that means it's from 0 to 2 pi. So I'm going to graph the couple points that are given, which is 0, pi over 2, pi, 3 pi over 2, and 2 pi. And you're going to find your x's and your y's. So here x, when t is 0, our x is going to be 5 because cosine of 0 is 1 times 3 is 3 plus 2 is 5. Do the same thing for the rest and you end up with 2, negative 1, 2, and 5. Same thing for the y's. So here we're going to plug in sine of 0. So sine of 0 is 1 times 2 is 2, negative 1 plus 2. Sorry, sine of 0 is 0, my bad. So then y is going to be negative 1, and then 1, and negative 1 for pi, negative 3 for pi, 3 pi over 2, and negative 1 here. So since we are graphing this based on the unit circle, we are going to start at 5, negative 1. So we're going to go out to 5, negative 1. Here's our starting point. Our next point is at 2, 1. Our next point is at negative 1, negative 1. So you notice in which direction are we going? Don't forget your direction. Our next point is going to be 2, negative 3. Our next point is going to be 5, negative 1. So here's why we focus just on this basic unit circle, because what happens after 2 pi? It just starts repeating. Okay? Alright, do the same thing here. Eliminate the parameter and the parametric equations, and then you're going to verify it on your calculator. The way you verify it on your calculator is you should be able to graph it, and you should get the same exact graph that we have right here if you graph both of these and the rectangular equation. So I'm going to give you guys the final answer And then you tell me why I wrote it in this way. And we'll talk more about this one tomorrow. So here is my rectangular equation. Okay, you could have left it in y equals, but you'll see as you are solving it that it's going to be easier to write it in this form. And remember, this is the circle equation, which makes sense because we graphed a circle. Alright, so time to bring on the calculus. So all of that was just review of pre-calc. So first off, before we get started, derivatives of parametric equations. If a smooth curve C, basically, it does not have any pointy place. So if we talk about a smooth curve, it doesn't matter how the curve looks like. Okay, the point is that there's no pointy area. Is given by this equation, x equals f of t and y equals g of t. So if it's given by a parametric equation, then the slope of C at any point x and y is given by dy dx. And the way that we get dy dx from a parametric equation is you take the derivative of your y equation and the derivative of your x equation and divide them. Okay? So this is the slope of C. Okay, so this is going to be the slope of your tangent line at a point C of a parametric equation. So nothing different. The only thing that's different is that now we are taking derivatives of two separate equations. And the reason why these two are equal is basically, think about it. If we had these two equations but we wanted to simplify an ugly fraction, we would flip the bottom guy and multiply, and you'd end up with dy over dx. Now just keep this in mind, but this right here, remember, when you find the derivative, it's technically the same thing as the velocity. And this right here is also equal to the slope of your tangent line. So it's the slope of the tangent line at a point. Alright. And of course dx dt can't be 0, because if it is, then the whole thing is undefined. Okay, so the derivative of the x equation cannot be 0. Alright, and then the second derivative is given by, this is the proof. I'm going to ignore basically all of this, but this is just basically saying it's the derivative of the first derivative. So it's the derivative of that dy dx divided by the derivative of the x function with respect to t. Okay? And then this little statement just basically says exactly what I just said. Okay. And if you remember, when we find the second derivative, what are we actually finding? Acceleration. And it also gives us our concavity. Okay, so keep that in mind. Alright, moving on. So, given x equals 2 square root of t and y equals 3t squared minus 2t, find the first derivative and the second derivative and evaluate at t equals 1. So to find dy dx, we have to take the derivative of the y function and divide it by the derivative of the x function. So what is dy dt? So what is the derivative of y with respect to t? So we're going to take this equation right here, and of course it's 6t minus 2. Now what is dx dt? It's going to be the derivative of this equation, which is, rewrite this as, I probably should have done some side work, but if I rewrote this as x equals 2t to the 1/2, right? You bring down the half and subtract 1, so this becomes 1 over the square root of t. So now that we have our dy dt and our dx dt, we know that our dy dx is 6t minus 2 divided by 1 over square root of t. Of course, you can't leave it like that, so we clean it up. So it's 6t minus 2 times the square root of t. And then the second part, we're going to use this to evaluate at t equals 1, dy dx is equal to 6 times 1 minus 2, square root of 1, which is 4 times the square root of 1, and that is 4. Okay, so basically this is giving us the velocity. That means this, whatever it is moving 4 units at a time. Okay, it's not a story problem, so we can't really give it a definite answer, but that is the slope of this curve at this point. I left myself very little room to find the second derivative, but to find d squared y over d x squared, we take the derivative of the first derivative and divide it by the derivative of x. So the derivative of the first derivative right here, let you guys figure that out, and divide it by the dx squared, we should end up with 9t minus 1. So why don't you guys do this, and if you don't get the correct answer, then we'll talk about it later. And then of course you have to evaluate this at t equals 1, which will give us the acceleration at that point. Alright, you're going to do the same exact thing. Given x equals 4 cosine of t, y equals 3 sine of t, write an equation of the tangent line. So here we're actually going to write an equation of the tangent line. So we're going to need to write a equation of a line, y equals mx plus b, to the curve at this point. So the first thing we're going to do is we're going to use calculus to find the slope. Okay? And how can I figure out x and y? What is my x and y? Basically, the point that you're focusing on is when t equals 3 pi over 4. So when t is 3 pi over 4, what is x? You just plug it into the x equation and you will get negative 2 square root of t. And for y, you plug it into the y equation, which is 3 square root of 2 over 2. Alright, so this is it's a review. So I'm going to let you guys find the derivative and the second derivative. Actually, we just had to find the derivative because we're writing the equation. And remember to write your final answer in point-slope form. Okay? Alright. Now, example 7 uses different terminology. It says find all the horizontal and vertical tangencies given by these two equations. So basically, when you're asking to find the horizontal tangency, you are saying that whatever it is not moving up or down, correct? So basically, you're saying that dy dt is equal to 0. And vertical tangency means that it's not moving left or right. So for this one, you're saying that dx dt is equal to 0. So you want to find the point when whatever this curve is, for horizontal, it's not moving up or down. And for vertical, it's not moving left or right. So basically, we know that we have to find the derivative of y and the derivative of x. So what is x prime of t? That's going to be 2t plus 1. And y prime of t is going to be 2t minus 3. So now to find the horizontal and vertical tangencies. So what did we say for horizontal? It's when dy dt, or the derivative, of y, which is 2t minus 3, equals 0. So you solve this and you get t equals 3/2. And then the vertical tangency is when dx dt, or 2t plus 1, is equal to 0. So you solve this and you get negative 1/2. So these are the two times where you have a horizontal tangency and where you have a vertical tangency. So whatever it is that you're talking about is not moving in the other's direction. But we're not done here. Okay, we want to find the point. So we want to find x comma y for these two. So basically, I could make a table. And I'm going to ask myself, all right, when t is 3/2, what is x and y? So when t is 3/2, you plug in 3/2 into t, and you're going to get 3/2 squared, which is 9/4, plus 3/2, and that gives you 15/4. And what is your y? So 3/2 squared is 9/4, minus 9/2 plus 5 is 11/4. So the point of horizontal tangency is 15/4, 11/4. And we're going to do the same thing for the vertical tangency. So I'm going to figure out what my points are when t is negative 1/2. So I'm going to plug it in here, and I get negative 1/4 for x and 27/4 for my y. So basically the point of vertical tangency is negative 1/4, 27/4. Okay, pretty easy as long as you remember the definitions and what is being asked. All right, next one, the parametric arc length. So this is finding the length of a parametric equation. So again, this is very similar to the normal arc length. There's nothing different about this except for the fact that you are focusing on two separate equations and you're squaring them. Okay, so this is the equation that gives us the length of the arc from t equals a to t equals b. So these right here, of course, are parameters. So find the arc length of this given function. So just like before, we have to find the derivative. The only difference is that we have to find the derivative of two functions here. So x prime of t is 2t, y prime of t is 12t squared. And you plug it into this equation, and what is our parameter? It's from it's from 0. So that's your a, and that's your b. So it's from 0 to 1 of the derivative of x squared plus the derivative of y squared. You have to plug this into the calculator. I mean, you could clean it up a little bit nicer without a calculator, but if you plug it into the calculator, you get 4.4149. All right, I know I'm kind of going a little fast because I'm reaching 20 minutes, and I want to get out of here and go to lunch. All right, so that's arc length. Now the last page is just a summary of everything that I kind of just talked about. Okay, this is very, very important that you, I mean, not necessarily memorize this page, but understand that the derivative of x is the rate at which the x-coordinate is changing with respect to t, or the velocity of an object in the horizontal direction. This is the velocity of the object in the vertical direction. X of t and y of t is the position. X prime of t, y prime of t is the velocity at that time t. X double prime of t, y double prime of t is the acceleration. So nothing is different, okay? We're still doing the same thing. Now when you take into account both equations, the rate of change of y with respect to x, or the slope of the tangent line to the curve, the second derivative is the rate of change of the slope of the curve with respect to x. Okay, and so on. So I'm going to leave you guys with this. This is a no calculator problem. And good luck. Finish up the notes.